Question is, the anti-causal impulse response of y of n minus alpha y of n minus 1 equals to x of n is. Here anti-causal means the impulse response exists or non-zero only for n equals to minus 1 and equals to minus 2 only on the negative real axis, whereas 0 and greater than 0 of a value of integer n, the impulse response is 0. That means h of n equals to 0, n greater than or equals to 0, h of n is not equals to 0, n less than or equals to minus 1. Here y of n equals to h of n if x of n equals to delta of n, that is impulse function, that is h of n minus alpha of h of n minus 1 delta of n. N equals to minus 1, n equals to, that is h of 0 equals to 0, h of minus 1 is alpha h of minus 2 equals to 0, h of 0 equals to 0, hence alpha h of minus 1 equals to 1, hence h of minus 1 equals to minus alpha inverse. Similarly, h of minus 2 equals to minus alpha minus 2. See, h of n equals to minus alpha power n, hence h of n equals to minus alpha power n u of minus n minus 1. Question is, the signal x of minus n minus alpha can be obtained from x of n is. Here x of minus n minus alpha can be written as x of minus of n plus alpha, means x of n can be written as x of n plus alpha is obtained by shifting x of n left by alpha and then folding the x of n plus alpha signal, then we will get x of minus n minus alpha. So first fold or first shift left by alpha, then fold it, then we will get the option B as a correct answer. Identify the ROC associated with the given Z transform equation. X of n equals to minus of n u of minus n minus 1 plus 2 into 1 by 4 n u of n. See, from the given sequence x of n, it is a two-sided sequence, means the ROC is kind of a ring. Here see, x of n we can write as sum of two signals, which is x1 of n plus x2 of n, whereas x1 of n is left-sided signal, whereas x2 of n is the right-sided signal. Means here the ROC of x1 of z is mod z less than half, whereas ROC associated with the x2 of z is mod z greater than 1 by 4. Hence option A is correct. Determine the Laplace transform and ROC for the given anti-causal signal minus e power at u of minus t. Here the Laplace transform, suppose f of t equals to e power at u of minus t. F of s is given as integration from minus infinite to infinite f of t e power minus st dt. So minus infinite to infinite e power at u of minus t e power minus st dt. Here 0 to infinite e power s minus a t dt. The integration converges to finite value if and only if the real part of s minus a is less than 0. That means f of s equals to minus 1 by plus 1 by s by if and only if real part of s less than a. Hence the option C is correct. Question is the minimum expression for the given Boolean function. Here f is given in the form of POS form, that is product of sum form, that is f equals to pi of 0, 1, 2, 3, 4, 5, 7. So we can find the minimum expression in the form of SOP, that is sum of products form, that is f equals to sum of 6, which is equals to xyz bar. Here the option A is correct. Question is for the network shown in the figure, the initial charge on the capacitor and the current in the inductor are 0. The minimum time after the switches are closed at t equals to 0, at which voltages Vx becomes to 0. Here the given data is IL of 0 equals to 0, Vc of 0 equals to 0. Here Vx equals to VL minus Vc. Here IL equals to IL of infinity plus IL of 0 minus IL of infinity into e power minus R by L into t. If we write the equation, this is IL. VL equals to L dIL by dt, which is equals to 100 e power minus 1000 t. Similarly, Vc of t equals to 100 of 1 minus e power 1000 t. If we equate Vc equals to VL, then we will get t equals to 0.693 milliseconds. Hence option C is correct. Here the question is, in the figure given, assume that the diode and the op-amp are ideal. For Vi varying from plus 1 to minus 1, the output voltage V0 will vary from. Here in the given figure, the circuit acts as a inverting amplifier, means there is a 180 degrees phase shift between the V0 and the Vi. So suppose Vi is varying from plus 1 means minus 1 to plus 1, means we can divide into two parts, that is Vi varying from minus 1 to 0 and 0 to plus 1. Whenever Vi is negative, output is positive. Vi is positive, output is negative. So in case 1 Vi is negative, suppose whenever Vi is negative, that means minus 1 to 0, V0 is positive. Positive means the diode is going to be reverse bias, which is going to act as a open circuit. In that case, V0 equals to minus 4 by 1 into, this is the case for Vi is negative, that is equals to plus 4 volts when Vi equals to minus 1. Similarly, V0 equals to minus 2 by 1, input is plus 1, that is equals to minus 2 volts when Vi equals to plus 1. That means Vi varies from minus 2 to plus 4 volts. Hence option B is correct.